What we're going to do is we're going to talk about Gaussian elimination. Gaussian elimination is a way of solving solving a matrix. And the matrix itself is used as a way of solving multiple simultaneous equations at the same time. So if we have an equation, something like this matrix is actually three simultaneous equations. This is the amount of x, this is the amount of y's, this is the amount of z's, and this is the number. So this would read 1x plus 2y plus 3z equals 3. And we put it into a matrix form so we can then make it easier to figure out the answer. So if I'm trying to convert this into an actual answer, I want to figure out what the value of y is. I want to find out what the value of y is, and I want to find out the value of x. And the easiest way to do this is using the Gaussian elimination. This is really good when we start getting on matrices of 3 by 3 or larger. So if we're going to do a Gaussian elimination, there are several rules. So if we have our basic matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9. Most people call these equation 1, 2, 3, but I'm going to call this one equation A. I'm going to call this row equation B, and I'm going to call this row equation C. It's just a notation. Most people go 1, 2, 3, but I think this is a little easier when we're working on the math, but use whatever notation you like in the test and exam. But when we're dealing with this, there are three basic rules that we can use or apply. Rule 1 is we can swap rows or swap equations. Because each equation is true in itself, that equation is correct, and that equation is correct. It doesn't matter if I put that equation there or there. So I can swap and say A for B. So I now go 4, 5, 6. So I shift this up. 6, 1, 2, 3, 3, 7, 8, 9. So that's rule 1. And as you notice, just because I shifted this equation from there to there, this is still true. 4, 5, 6 is still equal to 6. So it doesn't matter which row I put the equation on, that equation is still going to be the same as it started. Okay, so number 2 is you can scale equations. Basically, we can multiply the equations by a constant or by a number that's not equal to 0. So what I can go, if this is now A, I'm going to change this is B, C. So I'm going to go, this is going to go to 2 times B. I'm going to multiply that row by 2. So the first row does not change at all. The second row I now multiply by 2 because I've said 2b. So 1 times 2 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 3 is 6. 7, 8, 9. And this goes back to, as I said, remember, these are equations. If I have an equation like 2 equals 2, and if I multiply one side of the equation by, say, 2, and multiply the other side, it's going to remain mathematically true. So what I've done here is I've multiplied this side of the equation by 2, and I've multiplied that side of the equation by 2. Remember, that's effectively an equals there. That means this is still mathematically true, mathematically valid. So rule 1 is we can swap rows or equations. Step 2 is we can scale equations. And now for conceptually the hardest one, rule 3, we can add or subtract equations. This is the one that tends to confuse most people. So we'll call this A, B, C. So what I'm going to do, I'm going to subtract from here. I'm going to subtract, this row is now going to be A minus B. So I can add rows, I can subtract, but I'm going to subtract that row from that row. So the first row is not changed. 4, 5, 6, 9. But that second row is now going to be this row minus this current row. So 4 minus 2 is 2. 5 minus 4 is 1. 6 minus 6 is 0. And 9 minus 6 is 3. And the interesting thing here is because this has got row A and row B, I can use this to replace either this row or that row, because it's got bits of both in there. So those are the three big things. When doing Gaussian elimination, we can swap rows or we can swap equations. We can scale equations, so we can multiply both sides of the equation, or we can add or subtract rows. We'll do some examples in a second using augmented things. So the next video, or next two videos, will be examples working through this process.